Bismillah ar-Rahman ar-Rahim. We are going to continue on impulse and the change momentum. The impulse. We already found a relation between force and the change in momentum, correct? And we said that force, the resultant force, equal to the rate of change in momentum, delta P over delta T. If we are going to make a cross multiplication, we'll find that F delta T is equal to delta P. And we already deduced that delta P is equal to mv minus mu, the final momentum minus the initial momentum, find the change in momentum. And we have also F delta T. Both are equivalent to the impulse. F delta T, the force acting on an object during a small period of time, or whatever, the product of force and the time of the change, to give us impulse. And the unit of impulse is Newton second. And also the change in momentum is equivalent to impulse. And unit of impulse, in this case, kilogram meter per second. If there is any difference between Newton second and kilogram meter per second, it is the same. And you'll find that the unit of impulse is Newton per second and the unit of momentum is kilogram meter per second. So impulse and momentum both have the same unit. And I'm going to deduce it for you. Here we have Newton second. And if we are going to simplify it, Newton is what? Newton is kilogram meter per second squared. So second. We have second with per square, they will cancel each other. And what is left for us is kilogram meter per second. As we said, it is equivalent to Newton second. Now we are going to move to collisions. We have two types of collisions, elastic collisions and inelastic collision. Inelastic collision and elastic collisions. What is the difference between them? We are going to start by elastic collision, or we are going to assume that we have elastic collision. Elastic collision is rarely you can find elastic collision. Elastic collision is like the collisions between molecules of gas or between the molecules of gas and walls of the container. There is no loss of energy. Okay. Kinetic energy before collision is equal to kinetic energy after collision. If we are going to speak about elastic collision, we are going to assume that we have an object of mass m. m1 is moving with velocity v1, or I'm going to consider it u1, the initial velocity of the first object. And we have another object of mass m2 that is moving with the initial velocity u2. Science, as we said, consider momentum as a vector physical quantity, and since momentum is a vector physical quantity, it has magnitude and direction, and we need to take the direction in consideration. They agreed about making the right direction is the positive and the left is the negative. The negative for what? For the velocity, of course. So we have two objects. The first is moving to the right and the second is moving to the left. These before collision. After collision, what happens? Let's see what happens for the two objects after collision. After collision, M2 moved to the right with velocity V2, and M1 moved to the left with velocity V1. Okay, here is after collision. So before collision and after collision. At the moment of collision, the first object will exert a force on the second, and the second will exert a force on the first, equal in magnitude but opposite in direction according to Newton's second law. And also we have change in momentum. There is a law called law of conservation of momentum. Law of conservation of momentum. In this law, they state that if we have an isolated system no external force, the sum of momentum before collision equals sum of momentum after collision. So if there is no external force acting on a system, the sum of momentum of the two objects before collision equals to the sum of momentum of the two objects after collision. So if we're going to put this in a mathematical relation, we're going to say that M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. We are going to apply on our example here. The first object was moving to the right, was positive. So M1 U1 plus M2 negative U2, because the first object was moving to the left in a negative direction. And the second, after collision, what happens? M1 move to the left with negative V1 plus M2 V2. We are going to rearrange or rearranging the equation. We will have M1 U1 minus M2 U2 is equal to M1 minus M1 V1 plus M2 V2. Here is the law of conservation, the mathematical formula of law of conservation of momentum. The sum of momentum before collision equals the sum of momentum after collision. We can say that the collision is elastic when kinetic energy is conserved. The collision is elastic, number one, if kinetic energy is conserved. Don't say energy is conserved, because energy is conserved all the time. Don't say momentum is conserved, because momentum is conserved all the time, whatever the type of the collision. While in elastic collision, kinetic energy is conserved. It means velocity before collision equal to velocity after collision, or kinetic energy before is equal to kinetic energy after, and also velocity before is equal to velocity after. Okay. Regarding to the inelastic collision, let's move to the inelastic collision. Inelastic collision. The collision where energy is conserved, but kinetic energy is not conserved at this moment. We are going to assume we have two objects, the first object of mass M1 and moving to the right with initial velocity U1 toward the second object, which is at rest. So U2 is equal to 0, stationary object, M2. And we have a small sticky substance. After collision, the two objects stick together and move at a single object. Here is the first object, M1, with U1 and M2. And here is the sticky material. Sorry, I'm going to delete this. We have an error here. Mistake. The first object, M1, after collision, stick to the second object, M2. Here is M1 and here is M2. And the two objects move together with velocity V1 and 2. According to law of conservation of momentum, the sum of momentum before collision equals sum of momentum after collision. So momentum before collision is M1 U1 plus M2 U2. And here the momentum is equal to 0. and we have after collision m1 plus m2 with velocity v1 and 2. By resolving this, you will find that you can find the velocity. If you know the masses and we have the initial velocity, we can find the velocity after collision. Only substitute in this equation and you will find the collision. The last case, I consider it as exclusion. If we have two objects, for example, if we have two model cars and we have a spring balance between them, compressed spring balance between the two trolley cars, M1 and M2, and we have a spring balance. If we are going to release the spring and the force between them will be equal, the first object will move to the left and the second object will move to the right. Before collision, they have the energy is conserved, and of course momentum is conserved, and the momentum before collision is 0. So the sum of momentum before collision is 0 because u1 equals 0 and also u2 is equal to 0. So momentum before collision is equal to 0. After collision, what happens? M1 start moving to the left with velocity v1 and m2 move to right with velocity v2. And at this moment, the sum of momentum is the same because momentum before collision is 0 and momentum after collision is m1 negative v1 plus m2 v2. And if we move this to the other side, it will be m1 v1 is equal to m2 v2. So the product of the mass and velocity before is equal to the product of mass and velocity after, and you will find that mass is inversely proportional with velocity. It means if mass increases to the double, velocity will decrease to half, and it means that the relation between them is in elastic collision. The relation between them is inversely proportional. And we are going to stop here, and I'm going to record the video for solving some problems related to momentum. I wish you all the best until I meet you again. Assalamu alaikum wa rahmatullahi wa barakatuh.